In this example, we're going to read through this situation, define a couple of variables, and then write and solve a system of equations. So a local high school is selling tickets to the spring musical. On the first day, Julia sells 62 adult tickets and 27 student tickets for a total of $631. On the second day, she sells 48 adult tickets and 18 student tickets for a total of $474. Determine the price of both an adult ticket and a student ticket. So based on this situation, it looks like the missing values we're trying to find are going to be the price, and we have an adult ticket and a student ticket. So when I define these variables, it looks like A could be the price of an adult ticket. And in parentheses, I'm going to put a dollar sign because those are the units we're using to measure this variable A. And S is going to be the price of a student ticket. And again, I'm going to put a little dollar sign in parentheses, indicating that that's going to be the units on my S variable. Okay, so let's look at writing a couple of equations based on the information we're given. On the first day, Julia sells 62 adult tickets and 27 student tickets for a total of $631. So how can this be reflected in an equation? Well, 62 adult tickets and 27 student tickets brought in money, right? So our units are dollars. Well, that's nice because on our variable, the units are dollars. So 62 adult tickets. How much money are 62 adult tickets going to bring in? Well, it depends on the price of one adult ticket. Well, that's our variable definition right here, A, the price of one adult ticket. So if I write the expression 62A, this is going to mean the amount of money that selling 62 adult tickets is going to bring in from day one. So if I add to that 27S, which is going to be selling 27 student tickets, where S is the price of one student ticket, then these two will each be dollars, and when I add them up, that'll be my 631 that I made on day one. Day two is going to be something very similar. So on the second day, she sells 48 adult tickets and 18 student tickets and brought in $474. Okay? So just to be clear here on these equations, the coefficients, the 62, 27, 48, 18, these are the number of tickets that were sold, while the variables A and S were the price of each ticket, adult and student respectively. So when I do each of these little terms and multiply like 48 tickets times, well, each adult ticket is worth, whatever dollars, that's going to be the amount of money that 48 adult tickets brought in. So when I add the adult and student tickets for each day respectively, I'll get those total costs from each day. Okay, so now I have this system. The numbers are pretty big. So it looks like to me elimination is going to be the way to go. And it looks like the S's, well, 18 and 27, well, 18 is 9 times 2 and 27 is 9 times 3. And I know that by looking at these, it looks like 54 is the least common multiple because I can do 18 times 3 to make 54 and 27 times 2 to make 54. And in that way we can cancel out our S's. But of course right now they're both positive. So let's go ahead and make one of these negative. So they are equal in number but opposite in sign, so that when I add the two equations, the S variable will cancel out. Okay, so let's go ahead and distribute this negative 2 and positive 3 through our equations. So I'm going to have 124A minus 54S, and that's going to equal negative 1262. When I run a 3 through the second equation, should have 144A plus our 54S, which will cancel, and that equals 1422, I think. Okay, so our S's will cancel. So now when I add these two equations, I'll have 20A, and that's going to equal 160. So when I divide both sides by 20, A will equal 8. So A was the price of one adult ticket, so I know that that price is $8. Okay, now that I know the value of one of my variables, I can go ahead and plug that back in up here to find the value of the other variable. So let's go ahead and plug it into this second equation. So 48a plus 18s equals 474. So my value of a, it was 8 plus 18s equals 474. And 48 times 8, let's see, 384 plus 18s equals 474. And now we're going to keep trucking to solve this. So minus 384 from both sides. We have 18s, and that should equal something like 90. So when I divide both sides by 18, my value of s is going to be 5. So based on my variable definitions, A and S were the prices for the tickets of adults and students respectively, and it's measured in dollars. So now that I know the values for A and S, I can go ahead and write my sentences. So I could say something like, an adult ticket costs $8, and a student ticket costs $5. Okay, so here we have our sentence, which kind of summarizes our word problem after we used elimination to solve the system.